Hello folks, we are taking the part 7 of our exercise 4.1. The problem number 13 is there. We are going to continue with this and we are going to see how the working is going to come up. You have got to show that 1 plus 3 into 1, 3 by 1 into 1 plus 5 by 4 into 1 plus 7 by 9 and so on. 1 plus 2n plus 1 by n squared is actually n plus 1 the whole squared. Let Pn represent the given statement, and to show that P of 1 is true, that means we need to show that 1 plus 3 by 1 is equal to 1 plus 1 squared actually. So LHS is 1 plus 3 by 1 is 3 itself, so that's 4. 1 plus 1 it's 2 squared, which is also 4. So you have LHS is equal to RHS, P of 1 is true. To show that P of k is true, we have 1 plus 3 by 1, 1 plus 5 by 4 and so on, 1 plus 2k plus 1 by k squared to be equal to k plus 1 the whole square. We have to show that P of k plus 1 is true, means we have got to show 1 plus 3, 1 plus 5 by 4, 1 plus 2k plus 1 by k squared, 1 plus 2k plus 3 by k plus 1 squared is equal to k plus 2 whole square. So you take the LHS, and in the LHS we have got so many terms, so that will work out like 1 plus 3 by 1, 1 plus 5 by 4 and so on, 1 plus 2k plus 1 by k squared into 1 plus 2k plus 3 by k plus 1 the whole square. So this much we know already. It will come to k plus 1 the whole square plus we'll probably have to solve that term, and then you have to get k plus 2 the whole square. So how do we have this term solved? It will be like equalize k plus 1 squared, k plus 1 in the numerator, so k plus 1 the whole squared plus 2k plus 3 by k plus 1 the whole squared. Yeah, sorry, it's not it will be a multiplication term because we are dealing with products. Actually we are doing the products for the first time. All this time we had all pluses in between. This is a product that's coming for the first time. So till here we have replaced, and this we have written here. Now incidentally this can get cut, and you can have, and then you can have this term left, which is k squared plus 2k plus 1 plus 2k plus 3. And what does that come to? 2k plus 2k, 4k, and this is 4. That's ready made. 4k squared plus 4k plus 4 is k plus 2 the whole squared, and that is exactly our RHS. That's how LHS becomes equal to RHS. Therefore P of k plus 1 is true, and from steps 1 and 2 by principle of mathematical induction we are done with the proof of this. So having got that, we can gradually move to our 14th problem. We have the problem in this way. It comes up like 1 into, these are all product, all this time we were doing the sum questions. Now these are product questions. It is 1 plus 1 by 1, 1 plus 2, 1 by 2 and so on, 1 plus 1 by n becoming equal to n plus 1. So how do we go about solving this? First we take, let Pn be represent the given mathematical statement. P, to show that P of 1 is true, means the first term 1 plus 1 by 1, and on the other hand you have 1 plus 1. So this is, obviously it is 1 plus 1, 2, and here also it is 1 plus 1, 2. So LHS is equal to RHS, therefore P of 1 is true. To show that P of k is true, means you have got to show that 1 by 1 plus 1 into 1 by 1 plus 2 and so on, 1 by 1 plus k is equal to k plus 1. And to show that P of k is true, means it is 1 by 1 plus 1, 1 by 1 plus 2 and so on, 1 by 1 plus k, and the kth term is 1 by 1 plus k plus 1, and this will become k plus 2. So let's consider the RHS, LHS, and here you have 1 plus 1 by 1, 1 plus 1 by 2, and so on till 1 plus 1 by k. The next term is 1 plus 1 by k plus 1. So this will become k plus 1, and then you have the last term which is 1 plus 1 by k plus 1. This we try to equalize into k plus 1 into k plus 1. So what happens? You have k plus 1 here. When we equalize it, k plus 1 plus 1 whole by k plus 1. That's what happens when we equalize. And incidentally, these two can get cut. You're left with k plus 2, which is your RHS. That's how we get the LHS to be equal to RHS, and therefore P of k plus 1 is true from steps 1 and 2. From mathematical induction, the statement is true. This is about our question number 13 and 14. As soon as we finish this, we'll be taking up the next problem in the next video. Thank you.